tracking wave-like disturbances over Africa. The research that connects them to convective complexes and hurricanes. Harold and Hillary, why they were both so special, and how one person covered them both. This is NTWC Live.
Good morning, everybody. Welcome to NTWC Live. It is the 27th day of September. We've been with you pretty much every week since the beginning of the hurricane season. We'll be with you till the end of the season as we continue to watch what's going on in the tropics. Good to have you all along with us today. Thanks to everybody who joins us week in and week out. Great program for you today. Dr. Kelly Nunez-Ocasio is going to be with us. Also, Mark Suddeth will be with us. We're going to talk about easterly waves, and we're going to talk about a couple of H storms. We're going to talk about both Hillary and Harold, which hit close to me, and we never knew it was out there in one of those kind of storms. So I'm anxious to hear what Mark has to say about that. Before we get started, I want to thank our sponsors, those who make this program a reality each and every week. Thanks to first USAA. USAA, a big part of what we do at the National Tropical Weather Conference and the Storm Science Network. They've been with us since the very beginning, and we appreciate that very much. The South Padre Island Convention and Visitors Bureau, the host of the National Tropical Weather Conference. We'll be back there again the first week of April, the week before the eclipse. So make your trip to Texas, come to South Padre, then head up to the Hill Country and watch the eclipse the week after. Kind of bundle your travels this year. What a great idea. Also, the Weather Company, the company that provides graphic systems for television stations across the country. They're part of what we do. We appreciate that. And finally, Weatherboy sponsors college students come to the National Tropical Weather Conference every year. We appreciate that. So Weatherboy, thank you for what you're doing to be part of this. Of course, also with us today, Dr. Hal Needham, Hurricane Hal, we call him, and Bill Reed, former director of the National Hurricane Center. So let's start with Bill. Good morning.
Morning, Tim. Sounds like a typical summer day still down on the island. Same thing here. So it's a quiet reminder that even though it's, quote, fall, we're still deep in hurricane season. And we got some interesting discussions today, and I'll begin by introducing our first guest. Kelly Nunez-Ocasio is an advanced study program postdoctoral fellow at the Mesoscale and Microscale Meteorology Laboratory at NCAR. Her research focuses on better understanding of the processes that involve the evolution of easterly waves, the role mesoscale convective systems play, and the genesis of tropical cyclones. Her interest is in how convective processes and moisture play a role in the genesis of tropical cyclones and how these interactions will involve in a changing climate. And welcome, Kelly, and we'll get back to you in a moment. I'd like Hal to introduce our other guest, face familiar to most of the people online today. Hal?
Thanks, Bill. Great to see you this morning. I'm really excited to introduce our other guest, Mark Suddeth. Mark is an entrepreneur in the hurricane business. He owns Hurricane Track and tracks down landfalling hurricanes with remote video systems. If y'all haven't seen his video footage, it is amazing. And we're so excited to have you on the show, Mark. Another thing about Mark, he's worked with various news networks and recently with Fox Weather. And if you get to know Mark, you also know he's a huge Duke Blue Devils fan. Mark, welcome to NTWC Live.
Good to be here. Thank you very much. So who's going first? I know Bill talked about Kelly. Is Kelly doing hers first or me?
I think so. I think we'll work on Kelly first.
Great.
We have not done, I looked at all my notes and past things. I don't think we've done anything on easterly waves in any of our shows, which is, it's bad on us. Got to crack our knuckles on that one because that's an important aspect of the whole deal with North Atlantic tropical cyclone world. So I guess, Kelly, the first thing we'll ask you to do is describe what it is your position is out there and what you're working on.
Well, thank you, Bill, and thank you all for having me and for this invitation. I'm happy to be here. As you mentioned, I am a postdoctoral fellow at the Mesoscale and Microscale Meteorology Lab at NCAR. That's the National Center for Atmospheric Research. And my research is primarily on tropical meteorology, specifically easterly waves and how they evolve and how they interact with these convective systems, these thunderstorms over the African continent and eventually become hurricanes. And so I've been investigating how these features interact with each other in such a way to understand whether or not these waves eventually will become hurricanes. At NCAR, I've been using now, in addition to observations, high resolution data to study these complex processes.
Fascinating. I guess we'll start with a basic question, because you never know who studied what on easterly waves, and I'm sure what I studied has been superseded over the years with a lot of new research. But exactly how do these easterly waves develop?
That's a great question, Bill. And for that, I'm going to share my screen real quick here just to have some visuals. Let me know if you're able to see my screen.
We have it.
Beautiful.
Great. So what is an African easterly wave? Well, over the northern summer months, we know that the Sahel, this is the desert over Africa, gets really, really warm, and the monsoon starts to arise. And so basically you get a lot of moisture and winds coming in over central and southern Africa, but the warm of Africa gets even more warmer with the desert and drier. And so this creates a temperature gradient over the continent and makes rise to what we call the African easterly jet, which sits right here in that gradient between dry and moist. And so that jet gets perturbed over the summer, and that is where primarily the African easterly waves arise. Let me show you another visual, a more schematic type of visual. So the waves get perturbed, and these are basically how they look like. So they have a region that we call an inverted trough and a region that we call ridge. So it primarily has two regions. It is in the trough where conditions are favorable for MCSs and convective storms to couple to the wave. And so they propagate over Africa, and eventually once they hit the waters over the Atlantic, there's a chance that they can become hurricanes. But it turns out that not all of them turn into hurricanes. And this is where the complex of studying easterly waves really comes about, because we are yet to understand why some do turn into hurricanes and others don't. And that has been the focus of my research, Bill.
That's very good. The connection between the easterly waves and the MCSs, what have you learned about how that evolves, especially over West Africa before they come out in the ocean?
Thanks for that question, Bill. And I have a couple of answers to this question. So it's a very intrinsic relationship between the actual synoptic scale wave that can arise from the jet and the actual smaller scale convective storms. So it turns out that one way they connect is through the initiation of the system. So as I mentioned, the waves can initiate from the jet, but it turns out that the waves can also initiate from high topography, just like convective storms. So as you may know, over Eastern Africa, we have the Ethiopian highlands. And the Ethiopian highlands are like a very juicy region where convective systems develop. And from a convective system, we have seen cases that easterly waves can be perturbed as well. So right from the start of an easterly wave forming, the system of cloud and wave are already interacting with each other. Well, one of the questions that my research have answered is the connection between where these waves form and their likelihood of becoming hurricanes in the Atlantic. So I found out, Bill, that those waves that initiate over Eastern Africa, the Ethiopian highland regions, are actually more likely to be the ones that turn into hurricanes in the Eastern Atlantic than those that initiate over Central and West Africa. And the reason is, if I go back to the satellite image here, these waves that initiate over these high topography region, they spend more time interacting with these convective systems that can come out from the ITCC, the Intertropical Convergence Zone, and they spend more time also propagating and interacting with moisture from the monsoon. And so in a way, my research has shown that these waves that initiate over Eastern Africa are more prepped to become eventual tropical cyclone seedlings as we know them.
Huh, okay. That's kind of new to me. I had not heard that before. That's interesting.
Thanks, Bill. And then the other really cool thing, I think, at least from my research, is that I found a direct relationship between the position of the convection of the actual cloud and the center of the circulation. So this is what I found, Bill. I found that for waves that do become hurricanes, so that's this diagram here on the left. So the inverted trough here is identified with this black triangle, and obviously the convective system is identified here with this cloud. And so what my research has found is that those systems that do end up becoming hurricanes or tropical cyclones in the Atlantic, the convection, the cloud, the thunderstorms tend to be moving at the same speed of the wave and right in the center of the circulation. And this was true even before the system reached the waters. Now, on the other hand, those systems that did not become hurricanes, the convection associated to those systems was more likely to move south of that center and moving slightly faster. So there was a completely out of phase with the center of the vortex. So all of that energy that's coming from that thunderstorm, all that diabatic heating, that in the end ends up supplying energy to the wave, it ends up being not used. And so those systems do not become hurricanes.
Okay, that spurred a question, a comment and a question there. It looks like another factor that would be having all the convection synchronized with the trough axis is providing a good moisture pocket for the storm that's come off. And by doing that, it also probably minimizes the impact of the cell layer that's just to the north of it. And the ones that don't develop, it would, with all the convection in the south, it's probably injecting a lot of dry air to the waves. That makes sense?
That makes a lot of sense. And that's actually what ends up happening. This spacing between convection and center of the vortex pretty much protects the wave vorticity region from intrusion of the cell, as you well mentioned. But it's interesting. There's a lot of research. Well, I won't say a lot, but there's a few research regarding the cell and how it affects easterly waves. And although some of them tend to say that the dry air intrusion is detrimental for the further development of these waves, some research suggests that the particles end up being CCN nuclei, where it can actually help for cloud formation. So it's still a pretty debatable topic.
Yeah. I can understand that. We've been down that road a few times in the forecast world. The frequency of the wave. So is there any, we're at a well-established El Nino. Is there any research that shows more or less wave activity based on the phase of ENSO?
That is a great question, Bill. And there has been some studies that had directly studied the relationship between ENSO, El Nino, La Nina, and African easterly wave activity and intensity. As we know, there's a direct relationship with actual tropical cyclone activity. So we know when we have a Nino, there's a chance of more tropical cyclone activity. Less tropical cyclone activity. Even I get confused. But in terms of easterly wave relationship, it's been very few studies, but they have shown that when you have warm episodes, there is an increase in African easterly wave activity over Africa. And the primarily reason for that is because you have a lot of more vertical motion that can promote convection over Eastern Africa. And so there has been studies that have connected ENSO to easterly wave activity and intensity. But again, it's a relatively new topic, interannual variability and its relation to easterly wave. And even more so, it's a new topic, how these waves will change in the changing climate.
Yeah, that was a question I really wanted to get into also, the aspects of climate change, of perhaps growing the droughty conditions over Africa down into the Sahel and all. Would that impact? Is that one of the things you're thinking about that might be an impact of the warming climate?
Yeah, this is kind of like where I want to lean my research next, because it's still a very new area of research where we can't still figure out how these waves, their frequency and intensity are going to be different with the warming climate. And so far, the studies that we have use global modeling, which, although gives us a good understanding of the larger scale type of atmosphere phenomenon, when we look into the closer, higher resolution, right, to better capture these convective storms and these relationships, they have trouble understanding. And so, as a result, we can't really understand what's going to happen with these waves in the future. And so the very few studies that are out there right now, what they're suggesting is that the African easterly jet, as I mentioned earlier, it's going to intensify, and that will probably intensify our future African easterly waves. We cannot say something about the frequency of these waves yet. And so there's still many unanswered questions. And I would really like to move towards that direction in my future studies.
Interesting. I guess that'll be a TBD for some time down the road on when we'll figure that out. As one of the challenges I had, and I think still exists, is in the forecast world, is models don't seem to do a great job of forecasting the future of waves identified over Africa for when they come off the coast. It's usually after they've come off the coast that we get there. Is that a correct assumption? And if so, do you have any ideas of improvements in remote sensing that might make that work better?
Yeah, Bill, that is accurate. And I think it's because of two main reasons. First of all, historically, the tropics have been deprived of observations. It's a region where we don't have as much as observation as we do, for example, in the US with our radar network and what so. But it's also a matter of these complex interactions. And so that's why forecasting is so difficult. And so there has been a lot of efforts in terms of adding networks of observations over Africa. We're constantly hearing about more satellites, and that's wonderful, but we actually are in need of having in situ observations over Africa in order to capture these waves, right, from the get-go, and see how they evolve and be able to give not only that data to our models, but be able to study it and better understand these relationships. And so what I've seen is that over Europe, for example, there's a lot of efforts in terms of adding networks of observations over the west coast of Africa. A lot of my international colleagues are working on that. In the US, a lot of field campaigns now have been focused in the tropics. For example, last year, I was at the NASA CPEC-CV field campaign, and I'll show you a little video here of me releasing a radio sonde. And we were out there in Cabo Verde with the NASA DC-8 aircraft. And on board, we had a lot of instruments, and we were actually able to complete 13 research flight missions. And in these missions, we flew into African easterly waves, mesoscale convective systems. We looked at the monsoon. And so all of this data is important, and it's a way, Bill, to add information and be able to add that to our models to inform prediction and inform our understanding of how all of these systems interact with each other. So there's definitely efforts there. There's more to be done, but there's definitely progress internationally on this topic.
That's interesting that in spite of all the advances in the satellite technology, there's still a important role of the traditional obs like surface observations and radio sondes.
Indeed.
Yeah, Hal, I'm hogging the show here. You got any good questions coming into your mind now?
Oh, yeah, Kelly, fantastic presentation. Really interesting to see this research. I was going to actually ask about the in situ observations. I lived in North Africa for several years, farther north from where you're talking about with the eastern tropical waves. I was more in the Sahara region, but again, it was extremely data sparse up there. I was going to ask you, do you think there are going to be some international efforts to try to increase the density of ground observations, and how might that work?
It's always been I don't want to say a struggle, but it's been complex. As we know, Africa involves many countries, and it's always politics always are involved in the conversation of how we can unify our scientific efforts and try to move the field forward. But what I'm seeing here is that early career scientists and younger generations of scientists in the field are really pushing towards this. And I think there is progress, and there's more about not only collecting the data these days, there's also more a movement about sharing that data, not only with the public, but with our international colleagues. And I think that is where the field is moving. That is where our science is moving, actionable science, be able to directly impact society and help build a resilient community. And that's all part of that. So I would say, there's progress. It may be slower than we want, but it's happening.
Kelly, let's just say that a miracle happened and you had funding for 10 new ground observations from Africa, and the politics aligned, the money aligned. Where would you put those? Would you scatter them out? Would they be more in the heart of the moist region? Would some of them be in the Sahel? Would a lot of them be more towards the West African coast? Where would you place those?
Oh, I love when they ask me that question. I would put a whole network right off the west coast of Africa, all the way up from the Sahel, up to the point where the monsoon starts, and then several right over the ITCC belt, and then a whole other network over Eastern Africa to capture that initiation of easterly waves and convective systems over the Ethiopian highlands. Thank you for that question.
Yeah, it sounds like you'd spread them out a little bit to capture what's happening in different places. Kelly, last question from me. When you see a really robust wave like approaching and moving through West Africa, do you get a feeling sometimes like, I think this has a maybe stronger chance than other people may think of it developing? Or do you sometimes get an intuitive feeling from watching this based on your years of research in this part of the world?
Thank you for that question. And actually, I do, especially how I mentioned my research have shown that those that initiate over in the eastern region of Africa have a better chance of becoming hurricanes. So I always am in the lookout for those eastern originated easterly waves, which end up being more juicy, quote unquote, and more primed as they coupled more easily with convection. And those are the ones that I actually end up looking into. But if you want to learn more about how these waves can actually become hurricanes, I would point you to some of my research as well in one of my latest papers, where I am showing a direct relationship between TC Genesis likelihood in the Atlantic and the monsoon over the African continent.
Thanks, Kelly. Really thorough explanation there. It's been really interesting to look at the research you've done. Hey, Tim, do we have any questions that have come in online?
We do. Let me jump in with a couple of these and we'll take our midway break. First of all, there's a question coming in about the water temperatures in the Gulf of Guinea. And do those have any impact on your easterly waves? How does that impact them?
That is a great question. And so there are two prime tracks of easterly waves. We call it the northern track, which tends to interact more with the African desert, the Sahel. And then there's the southern track, which these waves end up interacting more with the monsoon and even closer to the region of the Guinea coast. Now, more directly is the relationship between the convective systems and the interactions that are happening in that coast than with the wave. And so we have seen how sea breeze and land breeze interactions between the coast and the offshore waters can prime convection and support it to propagate over the continent. So I think the relationship so far is more towards the convective systems with the Guinea coast and the mechanisms that are happening there than with the wave. But that is a great research question right there.
There's one other question from online, then we'll take our break. Would a positive Indian Ocean dipole have an impact on increased frequency of Ethiopian highland systems? And I have to read these questions because they're up there.
That is a great question. And I'll be honest, I have not studied the dipole directly, the Indian dipole, but I will say I have found connections between the Somali jet over East Africa and the Indian Ocean and likelihood of genesis. And when the Somali jet is more intense, we do see more convection activity over the Ethiopia highlands, and that helps both convection and waves. I hope that answers the question, at least to some degree.
That sounds good to me. Okay, let's take a break. And Kelly, you can stop sharing your screen. Thank you for that great presentation. Really informative and really interesting stuff. We do want to thank our sponsors once again who make this program a reality week in and week out. We'll start with USAA. Thank you, USAA. Also, the South Padre Island Convention and Visitors Bureau, the Weather Company, and Weatherboy. These are the companies that make it so we can do these shows every week throughout the hurricane season, and so we can be live in person on South Padre Island in April. And we'll be there first week of April of 2024. We hope you'll join us in person there and come hear some great presentations there as well. Okay, let's get a tropical update. We're still in the heart of hurricane season. Bill, bring us up to speed on what's going on in the tropics today.
Okay, let me put some pictures up there because they say it better than I do. Oh, wrong. Almost left the call.
Ooh.
There we go. I'm going to start quoting Mitt Romney at my technology thing of, darn it, why did that come up? There we go. You see my screen now?
We're good.
We're good.
Oh, good. Okay. You never know. My Zoom was acting weird there. Anyway, here we are this morning. There's, as we've talked about before, as we get to the end of September and October, we look down here for development in the Western Caribbean, and golly, there's a lot of thunderstorms there, but it's a steady stream of tropical moisture being pulled northward from the mid-latitude westerlies up over the Ohio Valley right now. And none of the models, the currently observations are nothing in the low-level circulation, and none of the models do anything with it other than produce copious amounts of rain on the Florida Peninsula, which they probably are welcome to since they didn't have a very wet summer. Out here in the Atlantic, we have our two systems that we've been following, Philippe to the northwest, and what might become Rena in the next several days. It still doesn't look healthy enough to me, and we'll get to their outlook in a moment here. This is a visual of that captures both of them, and you can see, as it has been its whole life cycle, the convection on Philippe is detached from the surface low. And as long as that's going on, the chances of it doing much in the development world is pretty low. You can begin to see some cyclonic turning, at least in three quadrants of the disturbance that we're watching that might become Rena. But the convection is up and down, keeps on going. A lot of arc clouds in there, which are indicative of maybe some dry air impacting it on there. The Hurricane Center, there's the area where it's essentially imminent. Any time we get a consistent convective signal in there, NHC will start issuing advisories on this system. But as for now, it's still just outlooked. Philippe, earlier on in its lifetime, we had high hopes of it becoming another oceanic hurricane and tracking northward, and to humble the forecasters to think they've got it all figured out. Philippe had other things in mind, and is a weak tropical storm expected to do further weakening, perhaps holding together till it gets to the Northeast Caribbean as a tropical storm. But essentially, at the strength it's at, it's a rain event, not a wind or surge event for the folks that live in there. Let's see what else I got. As for 91L, very consistent for 24 to 36 hours on the guidance that the supposed center of this system will be moving northwest. Then the models basically bend it back to the west, following kind of just south of the track that Philippe had, and the spread, as you might expect for as yet to be developed storm, is fairly wide. And the traditional guidance intensity, there's the H-Wharf must have gotten into some magical mushrooms, because it's way off the beaten track compared to any of the other models on this storm, and it also tracks it farther north, so it's on to something different. It doesn't seem like a likely outcome. And again, at least for the actionable forecast period, it looks like it'll be maintained as a tropical storm by the models. You're looking at the ensembles, the big signal I get out of this is that there's a lot of noise. We don't know basically, we don't know exactly where it's going to go, and the members that take it north are the ones that make it a strong cyclone, and the ones that take it further west don't. The thing of beauty for us is, given the time of year, is the almost pure absence of anything Gulf of Mexico or Northwest Caribbean. GFS is a similar solution. Again, the widespread on what the 91L system is going to do. It also picks up on at least from what I could see in the models, a non-tropical low on a frontal boundary off the East Coast. Maybe we can gin up another Ophelia-like thing. I don't know how many of you out there look at this sort of stuff from the Climate Prediction Center, but this basically talks about roughly what the conditions would indicate. It doesn't specifically talk about any development. And the hashed red and white striped area, those are just a slight risk, but at least in the case from the climate modeler standpoint of view, the environmental conditions are not totally hostile for tropical development, Eastern Pacific and Southern Gulf or Northwest Caribbean. But that's it. Nothing imminent that you can hang a hat on any of that stuff beyond the 7-day period.
Great, thanks, Bill. Now we know what's happening, and we're getting to the, for Texas at least, Bill, we're getting what traditionally getting close to the end of our season, but this year, I think all bets are off just because of the way it's been. Yeah.
That Harold will be a storm that 3 years from now, you say Harold, and everybody will look at you with a question mark because the impacts were fairly minimal.
It was near here, and I've already forgotten about it. So it took about 3 weeks, I think. So you're right. So, all right. Thanks, Bill. We appreciate that. Hal, you got a GeoTrack update for us, and then we'll get over to Mark Sutton. Hal, good morning again, and take it away.
Yeah, thanks, Tim, and thanks, Bill, for the tropical weather update. Well, hey, a quick update from GeoTrack. GeoTrack travels the world sharing stories with you about extreme weather and natural disasters not covered by the mainstream media. Check out our latest podcast episode number 79, a conversation with Warren Fadley, America's premier storm photographer. Warren's been at it for decades, covering amazing photographs from photogenic lightning to powerful tornadoes, hurricanes, blizzards, even monsoon rains in the Southwest. He's covered it all. And we have the in-depth story and how he got involved in this line of work, and really amazing stories from his decades of work out there in really extreme environments. A few of the stories that we picked up on this podcast were, number one, Warren really stressed the importance of enjoying the power of Mother Nature, but being aware that there's a fine line between enjoying this and being reckless. And so you don't want to put yourself or others in harm's way when you're out there documenting a tornado or a hurricane. So he gives some insight and some perspectives on that. He also shares about some hidden hazards that people might not be aware of. You know, we all think of floodwaters as being very dangerous as we watch the power of floods wash away buildings and cars and sometimes even people. But sometimes people get blindsided by just the nature of standing in pooled floodwater. And they may not be aware that there are all kinds of problems when you stand in floodwater and your skin gets exposed. So if you're in an urban environment or suburban environment, you can have a lot of pollution in floodwater. You can have sewage backed up. There are all kinds of contaminants in floodwater. You do not want to be walking through that with flip-flops, for example. And those of us that are storm chasers, Mark Sudduth, I know you've been out there videoing for many years. You've probably seen a lot of people just walking through polluted floodwater at sometimes. Another thing that Warren talks about on this podcast is the danger of something called Vibrio. It's a bacteria that can form even in rural environments, especially in warm salt water and brackish water, especially when you get water temps up in the mid to upper 80s or warmer. You can get this Vibrio bacteria. If that comes in contact with an open wound, you can get very sick, and this can even be fatal in some cases. So be really careful if you're out there and your skin gets in contact with floodwater. Finally, the last thing that Warren talked about is just the importance of making sure that your insurance is in line if you live, especially in a flood zone or a hurricane zone. A lot of people think their homeowner's insurance will cover flooding, and it won't. Or other people have a flood policy and they just didn't read the fine print, and they don't realize that, for example, their structure may be covered by flood insurance, but their contents may not. We hear of this all the time, that people go to submit a flood claim to their insurance, and then they're blindsided by saying, what do you mean my furniture isn't covered? What do you mean my appliances are covered? And here in the fine print, they never had their contents covered. So that was another thing that Warren mentioned, making sure you understand your insurance policy and making sure that you have all of that taken care of before there's a flood or hurricane strike in your region. Again, check this out. It's podcast number 79, wherever you listen to podcasts. It's on Spotify, Apple Podcasts. It's called the GeoTrek Podcast, GeoTrek. And it's a conversation with Warren Fadley, America's premier storm photographer, that just launched yesterday. Bill and Tim, thanks so much for giving us a chance to share a little bit about a GeoTrek Spotlight. And let's go back to the conversation we've been having this morning with Kelly and Mark.
Yeah, that's terrific. I love the conversations that you have with people who are in the middle of things and you know, traveling into the storm zones but the people stories you come back with are always amazing. I think Warren's talk should be great. I can't wait to hear it. Thanks, Hal. Appreciate that. All right, back to you guys to bring in Mr. Mark Sudduth. Speaking of photographing storms in a unique way, Mark has found a way to do that many times over and over, and it just keeps getting better and better. So guys, I'll jump in, take it away.
Yeah, Mark, you've been at this for a number of decades. I can't wait to ask you a lot of questions about how you've got involved in video surveillance and recording storms. But before we do that, I think you had a question for Kelly and her research before we talk about your research.
Yeah, just real quick, sort of the differentiation between tropical waves and these impulses or MCS systems that we get, non-tropical areas of low pressure that come off the United States that, for example, gave us Arthur in 2014 and Danny in 1997. I'm sure there are other instances where we can track these over the United States. Are they similar to tropical waves, or are they completely different?
That is a great question, Mark. It turns out, funny that you mentioned Arthur. I flew into Arthur back in 2014 with the NOAA Hurricane Hunters. And it was an interesting one too as well. And it turns out that, these mid-latitude types of systems are different from these tropical mesoscale convective systems. But you do have sometimes the chance where these mid-latitude types of systems provide a favorable environment for a tropical or subtropical system to develop, which was the case for Arthur. Sometimes we see mid-latitude troughs. They have specific names scientifically, but they do end up priming the region with moisture so that if there's already an existing disturbance, it can turn it into a subtropical tropical event. But these are, as you mentioned, primarily different from those MCSs, mesoscale convective systems, that initiate over the tropics.
I appreciate that. I mean, they're all seedlings, I guess, at the end of the day, the different genesis points. Grapes on a grapevine, you know, whatever the grapevine itself is, the grapes come off of it and they ripen in certain ways. We call those eventually hurricanes, and we see them come off the United States sometimes. Of course, the African easterly waves, your research is based on. I just think it's really interesting, all the different ways that they can form. Joaquin 2015 was an upper level low that worked its way down. And I know this is supposed to be what I did in Hillary and Harold, but this is just really interesting because we don't get to where I'm in the field without Genesis. So that's a good way to segue into my part. So thanks for that, Kelly. I appreciate the insight.
Yeah. I appreciate it as well. Thanks.
Thanks, Kelly, and thanks, Mark, for the insightful question. Mark, let's talk a little bit now about your field work. I mean, you've been out there in the field for a long time doing video surveillance, video recording. How did you get involved in this type of work, and really, when did it start for you?
Started, I guess, as a child, and growing up in Eastern North Carolina, always heard the stories of the graveyard of the Atlantic, and we had 4 distinct seasons, still do, although the winter seems to be getting shaved off a little bit more in the last 30 years or so. And then just really getting introduced to the weather by my father and his sailing expertise. And then in the early 80s, with the advent of cable news, it was available all the time. And it was just this constant feed of information, especially from the Weather Channel. And then just learning from local meteorologists, eventually studying it in college, going the route of geography and more the impact side of things in history and climatology rather than differential equations and all the math and the physics. I wanted to be more of the impact person. So kind of like being a storm chaser with a degree, but they don't have degreed storm chasers yet. That should be a thing. Maybe something like OU or Mississippi State University. I mean, they're churning them out anyway. Why not have a storm chasing degree, or at least they call them researchers, but that's pretty much it. You know, growing up where the weather was got me interested in it, and the technology has really allowed us to do a lot over the last almost 20 years, and really the last 5 years, an even bigger leap with everything getting smaller and smaller, so we can put these boxes, and not just video, but collecting the barometric pressure data and the wind data. Very challenging to do. In situ data is very difficult, and it's evolved. It's come a long way, and we've had a pretty active season overall. Hillary out in California, which I'll talk about, and then Harold in Texas. And then I'm going to throw a little bit of Adalia in there as a add-on, because that was a pretty significant event, of course, for the west coast of Florida.
Mark, I know you cover all kinds of extreme weather. Let's just talk about hurricanes, though. In general, when you get out there ahead of a hurricane impact and you're on the ground setting up a network of cameras and instruments, what are you trying to document? What are your main priorities out there, say, the day before the storm? How are you setting up instruments, and what are you trying to collect and document?
Well, storm surge is typically the most damaging and certainly has the most potential for loss of life. It can be the most dramatic, you know, because of the power of water. I mean, the water made the Grand Canyon, so it can obviously change our landscape. And I've always been fascinated by how water interacts with the human imprint and just the geologic landscape as a whole. And I think that's part of why I'm fascinated with how hurricanes interact with the desert Southwest, which is similar to what we'll talk about with Hillary, but really just trying to figure out where the biggest impacts are going to be based on surge modeling and the information coming out from the National Hurricane Center. I've collaborated with them numerous times over the years to try to understand better. And then they even watch the feeds live in the operations room, which is very helpful to them. As an example, Newburn in Florence in 2018, they were able to watch as that record storm surge came in from Union Point, right down there in downtown Newburn, where I grew up, where I got my start, watching that forecast verify in real time. That's part of the process. How can I help the scientific community? How can I help people that just want to see? And then how can we tell the story? And being able to spread these across such a big geographic area now, we can tell that story more completely. And we use that in conferences, some of the data. I share it with the Hurricane Center, universities, coastal engineers. And then, of course, I make these documentaries that I put on social media to kind of tell the story visually, musically, and with a storyline of the beginning, the middle, and the end of each one of these adventures.
Mark, you talked about the National Hurricane Center watching live the storm surge from Hurricane Florence on your network. So, I mean, are most of your cameras live feed nowadays, Or some of them just recording without a live feed, and you're going to go back afterwards and access the video? How does that work out?
A majority of the video process is live, and then certain ones we will put either a GoPro camera system, which is like this box here, or and we actually have much smaller stuff now. It's amazing. It just depends on the situation. But we started now using a camera from Axis Corporation, a little Axis cam, AXIS, that has a chip in it up to 1 gigabyte. And I'm going to show a little bit of that from Idalia, that we were able to use that at Cedar Key for the first time operationally, and it records onto that chip no matter what. But in cases like Hurricane Michael, we had the live feed at Mexico Beach, but then we augmented that feed with that very box back there with a GoPro cam, just a little old Hero 4. I mean, these things are like probably $80 now on eBay or something. And it recorded that Category 5 hurricane, no problem. It could have been swept away. We just got very lucky. And Max Olson last year did such a great job in Fort Myers Beach, taking this idea and expanding on it in his work. And that was all recorded. But look at what it captured and look at what it has shown. And we'll use that for years. The Hurricane Center's used it, and it'll be a good educational tool. But most of it is live, to get back to your question, because live is what everybody really wants to see. But when it's over, some of these that capture in 4K now, you do have to go back and get them. We do. And that could be a little bit of a, are they still there? Did it fail? Did the gremlins show up and screw everything up? There's always that worry. So live, if we can do it live, we prefer that. But sometimes the network goes down. We got to rely on these guys to back everything up.
Mark, you talked a lot about your field work already this season. Did you have some video to share with us?
Yep. Let's do that. I'll go quickly here, share the old screen, jump over to my folder. So this is the moderate to high risk that was set up out there in the West for Hillary. And I was like, all right, I've been to the desert Southwest enough times for the monsoon. I know the area pretty well. That training, if you will, going out there for years and years for the monsoon. And even back in 2014, for a couple of hurricanes, Norbert and Odile, that brought impacts to the Southwest, I was familiar with the area. But California, that was different. And this is just a few examples via video. You got Joshua trees there. The video doesn't convey it, but it's humid. It's raining, tropical rain, and it's windy. And I know people can say, oh, the monsoon does that, no big deal. But this was not the monsoon. This was ex-Hurricane Hillary, still a tropical storm as it moved inland over California. That was quite a wild sight. Flash flooding is a big concern out there during the monsoon. And of course, when tropical cyclones interact with the region. This is over in Yucca Valley, and just some minor flash flooding going across the roadway there. These dry washes, they become very full, of course, but it's very disruptive. This is down in the Coachella Valley area near Palm Springs and that region. This is I-10. We're looking west, and that is just miles and miles and miles of mostly trucks. And our commerce relies on these trucks and the truckers. They were stuck for hours, and that just delays things. It complicates things. It makes life harder. And it just shows you, look, this is the Coachella Valley, and that is flash flooding and leftover flooding from a Pacific hurricane interacting with the desert Southwest. It was a unique experience, to say the least, and I can't wait to tell the story further when we finally get to this episode of our series called The Hurricane Highway. And this is just an example. I mean, look at the wind there. It's blowing pretty good. The turbines there in the distance, the sheets of rain. It was very surreal because you look over on the left and it says Los Angeles left lane. I mean, like, it was very odd. And then I had to jump on a plane quickly from Phoenix and get to Tim's neck of the woods, right? The Rio Grande Valley. Flew into Alex's neck of the woods first, of course, San Antonio. Made my way down to Corpus Christi. Harold came in and strengthened pretty quickly right before landfall. They typically try to do that, these storms. Didn't quite make it to hurricane intensity, but it didn't matter. Still brought some impacts. This is one of our new cameras that we had tested from Axis that I had brought with me and just, strapped it to a post or something that was right down there on the Corpus Christi waterfront. And I learned a lot from this, how that, I wasn't in Corpus Christi for come on, I'm losing my mind here. 2017, the big one for Texas. Help me out.
Harvey.
Oh, Harvey.
Woo, showing my age. Can't remember stuff. Harvey. I wasn't in Corpus Christi for Harvey. We had a camera and a weather station close by, but not close enough. So the big thing that I learned from Harold Harvey, whatever, right, is yes, this is going to be a very vulnerable location. And let's go back to that radar shot. When this is a category 3 or 4, or even a 2, right, with a well-developed wind field, Corpus Christi is going to be in trouble. And it really showed me that. It really emphasized that for me. Okay, now I really get it. I know our friend Morgerman, Josh Morgerman's been to Corpus for talks and whatnot, and he knows the Bay very well. To see it in person like this with, quote, as Bill likes to say, just a tropical storm, imagine what a real strong hurricane can do. It was a good learning opportunity. So let's go over to Idalia real quick. We were all very worried that this could be a significant, major problem. Luckily, it did weaken right before landfall. We set up quite a few assets across the area. This is my colleague Matt putting the live cam and a GoPro, and they're very small. They're like the size of lunch boxes now. This is in Cedar Key. This is a live cam on, I guess it's like a canal. This is what it looks like from its view. This is in Horseshoe Beach. And yes, this can go underwater and even stream live, and I'll show you. Then we did what I've always wanted to do, and that is to put a camera system inside of a structure. We worked with a local owner of a tiki bar in Cedar Key. Scott is his name, and he allowed us to put the camera box. This is one of those Axis cams on that piano there in the tiki bar, and it recorded some amazing stuff. We also have our weather station that we put out, one in Cedar Key, one up in Steenhatchee, and let's see what we got. One of the things we got, and this is really interesting, this is about a minute long. I know we're going to be up against the top of the hour here soon. This is a big mystery. Sometimes the cameras capture impacts of people. So this lady gets out. This is the day before. She parks her Cadillac there, takes a couple of pictures. There's not much happening. This was on Twitter. I will always call it Twitter, by the way. I don't care what anybody else buys it and calls it. And this went viral on Twitter because there's a mystery here. She takes these pictures, she walks away, and then through the miracle of editing, I go and I dissolve into, or whatever it is, or a wipe into the height of the storm here. And it's starting to really, ramp up in Cedar Key. Cadillac's still there. And boy, it's really cranking now. The water levels are coming up. We're going to break the record set from Hermine back in 2016. And that Cadillac is going to be basically flooded and destroyed. It's gone. It's flooded and taken out on the right side there. Nobody knows who that woman is. I have yet to find out where she is, if she's safe. There was a lot of speculation as to why she left the car there. That's not my place to judge people, but that was kind of weird. You have to admit, a little bit of a mystery there. What happened to the woman who left her nice Cadillac at Cedar Key, which, by the way, that's before, and then that's how high the water level got, a little bit higher than Hermine. I know the Hurricane Center will do their surveys, but it was quite impactful for Cedar Key. There's the Horseshoe Beach cam underwater. That was streaming live. It's only about a foot above the camera. You can't stream an iPhone, even if you have it in a life-proof case or a waterproof bag, from 10 feet into the ocean, because the signal can't get out. So the equipment could be fine, but you just can't get that radio signal out. So it goes about a foot underwater. And yes, we were streaming live from under the storm surge of Hurricane Idalia. Not the first time that's happened. We actually did that a couple of instances. Ida, I think, in 2021. We also had live video from underwater, maybe even Florence in 2018 in some instances. So that was pretty weird. What about the camera in the Tiki Bar? It did great, capturing the impacts from inside of a structure. And the surge came up several feet, all but wiped out most of the stuff in Scotts Bar, but through social media, his Instagram and whatnot. A lot of people came down and helped out, and they rebuilt quickly. It's a very popular dive. I can't wait to get back down there and have a drink, and off the clock, so to speak, right? Finally, as we wrap this up, the Steenhatchee River, normally it goes from right to left, and no problem, right? But then Idalia pushed the surge up the Steenhatchee, and all kinds of shenanigans took place because of that. You see the water level now going from left to right, and pretty fast. This is not time lapse, this is real time. And the boat ramp there collapses, and all kinds of stuff starts pushing up the river. I've always wanted to capture this phenomenon. I've seen it when it's over, all the boats packed in somewhere. When it's all done, how did they get there? Well, this is how. Like, there you go. And again, that's real time. That's not sped up. That's hauling. For the force of the Gulf to come up the Steenhatchee like that, that is remarkable. And the Caloosahatchee did the same thing in Fort Myers and vicinity almost a year ago. Look at all that. We saw that in Ike with a lot of stuff pushed up down there near Galveston, but nobody ever gets to see how it happens. Now with these cameras, we can, if you get them in the right place at the right time. Moving on along real quick, I went up to the interstate. I was not going to get into the core down near Perry. As they say, I choose life. That's just me. I don't like to be in the core of these nasty things if I can help it when I'm in an unfamiliar area, and I just didn't really think Perry would be real safe. Everybody did fine who was down there, but I went up to the interstate near Madison and got a pressure of 959 in the eye. That's what the eye looked like. It went right over me, and it was filling in or whatever, but you can literally see the low-level bands of the eye. I did a 360 here with the drone, and it was pretty cool to do that. The second time I've ever really seen a well-defined eye like this. The first was Dorian on the Outer Banks of North Carolina, actually, in the Buxton area in 2019. Very similar structure. I mean, look, you can literally see the whole curvature of the eye. I was like, wow, what a nice little surprise there for Idalia there. Now, real quick at the end here as I wrap it up, our wind and pressure sensors did great. No sustained winds really even above 40 at Steenhatchee or Cedar Key because the circulation did collapse. As we saw, it was that northwest quadrant that was more impactful. Got the pressure trace there. Always neat to see the inverted barometer effect. This one is Steenhatchee. The first one was Cedar Key. And in Steenhatchee, we did get a sustained wind at just above 40, mini gust above 60. This is in miles per hour. And the air pressure there, sub 980. We actually have the printouts of it to get exact measurements, but that's what we do. That's the data side. The cameras help provide data as well from a visual, and it's been quite a busy year despite the El Nino. So there, I think I've packed quite a bit in there with 3 minutes to go.
Mark, thanks so much. Absolutely fascinating footage and stories of your travels. Tim, Bill, we have a few minutes left. Any questions or thoughts from you guys?
Go ahead, Bill, if you've got anything.
Yeah, you always have something new show up every year after the season. What's in your mind for something new in the next several years for your work, Mark?
Well, we're going to branch out from hurricanes more. Hal mentioned that earlier, thanks to crowdfunding and in my work now with Fox Weather, really getting to explore my passion for weather elsewhere outside of hurricane zones. So we're going to really focus on hail research and observation, because it looks like hail is becoming a bigger and bigger problem. Alex and I talked about this over lunch a few weeks ago. I just think there needs to be more of a light, so to speak, shined on what's going on with these big hail events as a warming atmosphere continues to warm. It seems to be we're getting these bigger and bigger hail events, and it's not because everybody's got one of these now. These have been around for more than 15 years. We are seeing more destructive hail events, and I think we can use cameras to at least educate people. I don't know if we're going to be able to crack any kind of solve any problems, but at least educating people about the dangers of big hailstones. And I'm not getting out of it, and I got to keep this protected. So we're going to use these guys, probably more advanced versions of them, to study hail in slow motion and other things like that. So taking the hurricane work and expanding out into Tornado Alley for big hail events.
Are you familiar with the IBHS work on hail? Yep. You might want to talk with them on collaborating.
Agreed. And I mean, I think the big thing too is involving social media. and getting attention without being goofy. We don't want to do anything that's a stunt. So and I talked with Alex about this, like I said, but testing household stuff that we have outside, and then like car windows and solar panels, and put them on like a flatbed truck, put GoPros on them, see what happens in these different hail events. It's a big project, a big undertaking, but I think it'll lead to at least a lot more awareness that hail is becoming a bigger and bigger problem, pun intended.
And with that, we've reached the top of the hour. Great stuff, guys, and everybody. We appreciate it. Dr. Kelly Nunez Ocasio, thank you for your presentation today. Really, really interesting stuff. I'm going to go back and watch it again. It was that good. So thank you for that. We appreciate that.
Thank you so much, Tim, and for all the team. And I'll say really quickly, for those participants that want to continue to learn about my work, I'm on social media. You can find me in Twitter or X at KNubez. That's KNUBEZ, KNubez. I also have a mesoscale convective system tracker that is publicly available. So if you're a researcher in need of that, you can find that there as well. Thank you so much for the opportunity.
Perfect. Thank you for being part of the program. Mark Sutter, thank you. Always good to have you on, buddy. And I look forward to seeing you in the spring as well.
Absolutely. Can't wait to be back in Texas. Actually, I'll be there next month for the eclipse, the annular, but the big deal, of course, next April.
The first of two. We'll see you here in April, and then just drive up the road and see the other. Bill Reed, thanks as always. Great job today. And Dr. Hal Needham, thank you. Hurricane Hal, good job. And still watch that storm behind you, kind of mesmerized by it as it keeps churning back there. So thank you. We appreciate that. Next week, we'll have Casey Tringle, the director of the Louisiana Office of Emergency Preparedness, and Dr. Andrew Schroeder, Vice President of Research and Analysis with Direct Relief. So that'll be next week at the same time. In the meantime, thank our sponsors who are part of this program each and every week. USAA, the South Padre Island Convention and Visitors Bureau, the Weather Company, and Weather Boy, all the folks who make NTWC Live a possibility each and every week. So until next week at this time, take care, stay safe. We'll see you in a week.
Thanks, everybody.
We hope you enjoyed this episode of NTWC Live Hurricane Center Podcast. If you did, head over to Apple Podcasts and leave us a 5-star review. And join us next week. This is NTWC Live.